this video, we will look at an exam-style question of numerical solutions of equations. You will find this on page 569 in the Namibian AS-Level Mathematics textbook, y equals mx plus c to success. Let's look at another example. Okay, let's start. The polynomial px is defined by this. The diagram shows the curve y equals px, so there is the curve, which cross the x-axis at alpha and 0 and 3 and 0. There's the 2 points. Now, actually in this question, they're nice to help you a little bit. They say, divide px by a suitable linear factor and hence show that alpha is a root of the equation. Okay, now, if that you know that is a factor, let's rather make it red, because it's cutting the x-axis. So you actually know that x is equal to 3 is a factor. Okay, but if you take it over and you divide, remember it's actually x minus 3 that's a factor. But so I'm going to do division. You can also, and in the example which I will do after this, I will do long division. But just it's good that I just summarize quickly the short way because it spares a lot of time. So as I said, this is the factor. So always we put this 3. We bring down, we multiply, we write, we simplify. And then we multiply and we simplify. We multiply and then there, and then we simplify. So basically, and then don't forget, we usually write, this is the constant, this is x squared, and that is x to the power of 3. Okay, so it's actually x to the power of 3 plus 3x minus 60. Okay, now, I didn't include it here, but I'm going to include it just for you. It's actually saying that fx, okay, it's equal to, and if I'm going to write it, it's going to be x plus minus 3, sorry. Let's get that sign correct. And it's going to be x3 plus 3x minus 16. That, oh, sorry, the pen. Minus 16, the quotient. Okay. Meaning that if I put this is equal, this is where it cuts the x-axis. So that means in the place of y, there will be a 0. Okay. So where it cuts the x-axis. So it's mean either this one is 0 or this one. And that's the reason why I put it equal to 0 there. And now I just make x the subject, this x the subject, because I can see they are leading me and I have to look always. I cannot make that x, I can see it's to this one, because I see that 16 minus 3x and then I take the cube root. Okay, remember, it's always very important if we do this in this chapter, the way we manipulate the equation. And now they say, use the iterative formula, this, to find this angle correct to 2 decimal places. Give the results of each iteration to 4 decimal places. So remember, now again, they didn't tell you the starting point. Now, if they don't tell you the starting point, just take a value more or less in this. You can see there is 3. So, okay, so you can even take 1 also. It doesn't matter. And I will show you in the example that I'm doing that is really not such an influence where you take the value. But in this case, I was choosing 1.5. But you can also try it with 1. I'll show you now in the next. So program that into your calculator. Press 1.5 equals. Okay. And then press the cube root. So I usually have to press shift and then bracket 16 minus 3 answer and then equal. And then start writing. And remember, you must write it to 4 decimal places. 4 decimal. But every time, and it's always good to just already approximate to 2 decimal places. So that, I'm going to take red, is 2. Oh, my pen is not nice. 2.26. This is 2.10. This is 2.13 and this is 2.13 and there is the answer. So it's always good to already show that also. I didn't include it here, but it's always good. Okay, otherwise you're going to do maybe too many. And as soon as you see two consecutive numbers approximating to the same answer, then you know that that is your root. Okay. I want you to stop the video and I want you to do try now 10. And again, you can continue the video as soon as you are finished. Okay. Okay, I'm going to start here. I'm just going to make it smaller. Okay, let's start. The diagram shows the curve with the equation, and you know what I like to do, I always like to write that down, just as a starting point. And then, as soon as I wrote it down, I read it a little bit further, because that's now what I'm going. And that's also the curve that you see there. Okay. Diagram shows the curve with this equation. The curve crossed the x-axis at 2 points. Do you see? It crossed there and it crossed there. Okay, so at alpha and beta. Okay, now we go on. Skip to yellow. Use the factor theorem. Oh, and this they were actually more nice than this. This one they didn't tell me. So it's actually, this was nice. Okay, so because they tell you, first, use the factor to show that x plus 2 is a factor of that. Okay, and I know that that's coming from, I think, chapter 1. So I'm just going to say if, and then I'm going to say -2. I'm suddenly wondering, because they took 1 and 9, there's a connection between that two chapters in one of them. Okay. So if I substitute f minus 2, remember, because it's plus 2, so if you put equal to 0, then you take over. And then I'm just going to say -2, and just look at that exponent. Sometimes it's so easy to leave out 1, and it influences so many things. So especially there's a square, and then -2 minus 32. And then I'm just going to get 16. Minus 16, and then this is positive, so it's plus 4, plus 24, minus 32, and that will be equal. And please don't stop. We remember from that chapter, we always said that you have to end with therefore x plus 2 is a factor of fx. Okay, now we're going to go on. So that we're done with that. Now number B. Show that beta, this angle, satisfies an equation of this form. Okay, so basically, this remember that this value is now actually -2. Are you with me? And I'm trying to find that one. Okay, and how do I do that? So they show that this. Now, if they come, they actually just helped me, just like I know that 3, they helped me with the -2. Now, what did I do to get the extra? I did long division. And I decided that in this question, I will do the long division, just to revise that again a little bit with you. So if I do long division, I have one of the factors now. Oh, it's a little bit high, but it's fine. So I have x plus 2. I know that one. And I know it's going to be x4 plus 2x3 plus 2x squared minus 12x minus 32. Okay, and I start. If I divide, I get x to the power of 3. Then I multiply, can you recall? And I multiply. Oh, and this is very nice. Everything cancels because I changed the sign, I changed nothing. I bring that one down. It's a little bit too high there. Bring it down up to here. Okay, so I divide, and what do I get? 2x. Okay. So if I multiply, I get 2x squared, and if I multiply, I get 4x. And there's my minus 12 coming down. Now I have to move up a little bit. Okay, change signs. I like to make a circle to see that I remember to change. So nothing, negative 16x. I divide, I get negative 60. I multiply, I get negative 16x. Multiply negative 32. Bring down. And then this is a positive. This is a positive, nothing, nothing. Okay. Now, just remember, I just want to show you, the quotient is now, this is my quotient. I can basically write it like this. Okay, so if I have fx, I just want to show you, then I will have the x plus 2, and I have the extra, the quotient. Because if I multiply it out, I will get that again. Now, where it cuts the x-axis, y is equal to 0. So that is actually, I'll just show you what I'm basically, why I put that one equals. That basically indicates that either this is 0 or this is 0. And I want to come to that or. So I have x to the power 3 plus 2x minus 16 equals 0. Now remember, you have to look at that. Any way of manipulation is not going to work. You have to they lead you. Otherwise, you have to do, if you can recall from previous videos, you have to differentiate and you have to test and to see what manipulation. But usually, sometimes they're nice, they help you. And you can see, if you look at that, okay, so this is going, I'm going to take the 16 first, and then I'm going to take the 2x. I prefer writing the negative one at the back. Okay, and then it's 3, it's the cube root. So from this, so therefore, I can see the value of, I like always to go for my root, therefore in red. Therefore, the value of P is 16 and Q is negative 2. Okay, and now I will go on and state the values. So if don't forget to do that, you always read, before you go on, read your question and make sure you are answering what they asked. Okay, so now I can go to number C. And I want to do number C again here on the side. I just want to draw a line. Okay. If I look at number C, use the iterator formula based on B, so they want you to find the value of beta correct to 4 significant figures. Give the result of each iteration to 6. Okay, so this is quite a lot. So they want the final to 4 and every in between to 6. Okay. Now, you must look, you can look at the sketch also. There's the negative. So it's positive, you can see. Now you have to think, what do I choose? You can choose 1. You can choose 2. Now I'm first going to choose 2. But then I want to show you, for somebody who was choosing 1, you will end up at the same answer. But I'm going to start where I choose. I can see it's on the positive, so don't choose a negative. So I can see, let's choose it 2. What is my formula? It's x, n plus 1 is equal, okay, remember that's fx, your big, okay? And that is equal to p, oh no, I have p, I have to fill it in. So 16 minus 2x, and remember it's cube. Okay. Now, I'm going to just press in my calculator. And I'm going to do it both, and then I will do it with the other one also. And then I will say something at the end. Okay, but let's start with x2. So first, in your calculator, press 2 equals. And then you're going to program that formula. So go shift 3, bracket, 16 minus 2, answer, close the bracket, equals. Okay. What do I get? I get 2.28943. Remember, it must be 6. So 1, 2, 3, 4, 5, 6. But don't also forget to already approximate it to 4. So 2. There's 1, 2, 3, that's 4, 2.89. Sorry, I forgot that. 2.289. And then I go for x3. and that's 2.25 and 201. And if I approximate it, it's 2.252. And then I go for the next one. Press equal just. So it's 2.25692. And if I approximate it, it's 2.257. Then I go for the next one. So press equal. And that's 2.25627. And if I approximate it, it's 2.256. Then I go for my next one. It must be consecutive the same. Okay, so don't forget your equal. So it's 2.25636. And that's 2.256. Okay, I'm not going to finish off. I just wanted to show you. Do you see? That's the answer. I will now write the conclusion. I just want you to show you, and this is what I want. Say, for example, somebody was choosing 1. Other person said, okay, let's start. 1 is a good starting point. Okay, and I just want to draw this line. Okay. So, say, for example, you did exactly the same. Let's get my pen correct. Let's make it green. So, x1, but you choose 1. But your formula is exactly the same. So, let's then, the formula is exactly the same. I'll just write it now. To see, otherwise maybe you lost me. Okay. Now, press 1, press equal. Program it into your calculator. Okay, so go shift, cube root, bracket, 16 minus 2, answer, close the bracket, equals. Okay, so for x2, I get 2.4, oh, sorry, my pen. Come on, pen. 2.410, it's 1, 2, 3, 4, 5, and 41014. Okay. And if I approximate it, it's 2.41, yes, 0. Okay, equals, look like a little bit white, but, oh, here it becomes 2.2360, and then it's going to be 3. And if I approximate it, it's 1, 2, 3, it's going to be 2.236. Just going to move it up. So if I go for x4, let's just go. Then it's 2.25901. And if I approximate it, it's 2. So it's 1, 2, 3, 2.259. Okay? Then I go for my next one. And that's 2.2550. Now be careful for all that 9. So it's 1, 2, 3, 4. So it will be 5. Okay, that one will just be a 60. So 2.25600. And if I approximate it, 2.256. And then my final one is more or less the same. Equals. And now it's 2.256 and then 40. And if I approximate it, it's 2.256. And take note. So it doesn't matter if you start at 1 or 2. At the end, you're just going to conclude and say, correct. Let's just write it down. Correct to 4 significant, therefore, let me just get my pen. Therefore, correct to 4 significant figures, beta is equal to 2.256. Okay, I just want to show you, if you really want to find this in and you say 2.2555 or 2.2565, just remember the formula that you will work with is always with the small fx, and the small fx will just be, it will just be this and then minus x. So just take note. I'm not going to do it in this video, but it will be this one, which was that 16 minus 2x and a 3, and then subtract the x on the other side if you want to test the change of sign. I'm just mentioning it. I'm not going to do it in this video. This is my final answer.